Take a look at a wind farm. What do you see? Spinning blades, giant towers, wind turbines? What you probably won't see are the years of planning, permitting, and precise engineering that go into creating projects of this magnitude. Today, Shades of Green goes behind the scenes of wind power as we take an in-depth look of the most innovative technology involved in manufacturing key components of a wind tower.
FARO is a world leader in three-dimensional measurement and imaging technology, and our technology combines a combination of lasers, software, and portability to provide simple capture of extremely complex three-dimensional data. FARO is involved with a wide variety of different industries, everything from automotive and aerospace to heavy manufacturing and small machine shops, even crime scenes and forensics investigation, and of course alternative energy markets such as wind power.
Creative Foam has been called out to one of their customer locations to assist in the assembly of wind power blades. We are here in Howard, South Dakota at Knight & Carver's facility where the gigantic blades for wind turbines are manufactured.
Creative Foam was started in 1969 as an automotive supplier, and we eventually grew into the medical industry, and about 2.5 years ago decided to get in the alternative energy industry, primarily wind energy. We primarily make composite core kits out of different types of foam material to add lightweight structural stability to the wind blades.
In order for wind turbines to actually produce energy, it is critical that the dimension of these blades are exact. They must be wide enough to capture wind, yet light enough to spin.
It's very important that these kits are very dimensionally accurate, because to make maximum use of the wind, these blades are very highly engineered to catch the wind very precisely and maximize the efficiency of them. So every part of these blades is very highly engineered from a geometry standpoint and from a material and weight standpoint.
The FARO laser scanner is a portable measuring device that allows us to take measurements on large objects such as wind turbine blades. We set it up in front of the device and it sprays coordinate measurements onto it.
FARO's laser scanner allows Creative Foam technicians to actually see how each blade is shaped, allowing Creative Foam to determine the exact dimensions within 2 millimeters. The data captured on site is then transmitted back up to Creative Foam's headquarters located in Fenton, Michigan, where work can begin manufacturing the kits.
When we scan the surface of a mold, what we're trying to obtain is a 3D image of the surface of the mold so that we can use that accurately to create core kit parts. When Creative Foam decided to enter this business, we actually didn't know how to get the data that we needed. So we entered into a relationship with FARO, and we found the FARO laser scanner to be one of the few products in the marketplace that would give us the accuracy and the amount of data we needed in our 3D images.
Now that we have seen how blades are made, let's take a look at how FARO has completely changed the way one company, ATI Casting, manufactures the hub in which the blades rest.
The hub is the component that the blades bolt to. As a matter of fact, we have one right behind us. It also is mounted to the main shaft in the turbine and delivers the spinning, rotating power into the turbine. We produce a mold out of silica sand through a chemically bonded process. We mix chemicals with the sand and it sets up, forms a very rigid mold. There's two halves of the mold, the top portion, which is called the coop, and the bottom portion, which is called the drag. The mold is assembled and there are blocks of sand inserted into the mold to give the internal shape of the hub, and it is cast with metal that's poured at about 2450 degrees. It's made out of ductile iron. The metal is melted in coreless induction furnaces. After it's poured, it cools in the mold for several days, and then it's extracted. It's cleaned in a shot blast machine and then inspected. The FARO measuring devices that we use have accelerated the process of checking and confirming components are in tolerance. It actually speeds the process because, again, you can take the FARO equipment to the component. And as you can see, these components are very large. Hubs range in weight from about 20,000 pounds to 28,000 pounds. And there are many dimensions checked on them. So one of the greatest things about the FARO is the speed and the accuracy.
Upon completion, ATI engineers utilize either the FARO arm or the FARO laser tracker to ensure each hub has been manufactured to the exact specifications provided from the customer.
The hubs are, in effect, a critical safety device with the turbine. And the specifications for wind turbines are very similar to aviation specifications. So we have to have a high level of confidence that we have made a part that complies to all the specifications of our customers.
As we have seen today, FARO Technologies is not only advancing the wind power industry, but also setting standards across the spectrum of precision fabrication. From ensuring perfect measurement to speeding up the manufacturing process, FARO is breaking ground and propelling a booming industry.
Well, FARO is extremely excited to be part of a movement that will enhance everyone's way of life so much. As a company, our mission is to enable our customers' products and processes to be the best in the world, and we do that by improving efficiencies and conserving energy and resources. And so we're very proud to bring those core competencies to the wind power movement.
FARO Technologies is not concerned with cutting corners, only measuring them. The next time you see a wind farm, just remember there is much more that goes into these projects than what meets the eye.